Hello everyone. This video is going to be a quick demonstration of how to calculate the mean and the standard deviation from a data set. Now we'll start with a simple example where we just have 5 individual scores listed out. These could be anything. So first step is calculate the mean. Now as we know, the mean is the sum of the individual scores divided by the number of scores. In this case 8 plus 6 plus 7 plus 9 plus 4, and there are 5 of these things. So I should have had brackets on that to make it work, and then over 5. Don't forget we've got this key here to change from decimals to fractions, and so we get a mean of 6.8. That's good so far. Now the next thing is the standard deviation. So the standard deviation sigma is given by the giant formula, sum of the score minus the mean squared divided by n, and we take a square root of the entire thing. It's a bit of a nightmare, but practice it, remember it, you'll get it. Now let's decompose the formula and see what it's really telling us to do. Just like this meant sum of x, so just add each score, this means sum of this thing. What is this thing? Well, it's a score subtract the mean. In the first case, that would be 8 subtract 6.8. The next one would be 6 subtract 6.8, and so on. So let's see what we get. We'll have 8 subtract 6.8. Now we can do that in our head. It's important that we do the score first and we subtract the mean. So 8 take 6.8 is 1.2. Now we are to square this thing. So that's the first one squared. Sigma means keep on adding until you get to the end of the list. 6 take 6.8, that would be negative 0.8, and square the result. Keep adding till we get to the end of the list. 7 take 6.8, 0.2 squared. I might put brackets on the first one just to make it neat. Keep adding till we get to the end of the list. 9 take 6.8, that's 2.2 square, each of them squared. Keep adding till we get to the end of the list. 4 take away 6.8, well that's a hard one, that's negative 2.8 squared. So we've added the differences or the deviations squared. That's a deviation, squared it. Next one, squared it. And we added the whole list. Divide by n, divide by 5, and finally put the radical sign, the square root sign, over the entire thing. Clearly, setting it out like this is only practical when we have a very small number of items in our list. Really, this is a demonstration to explain the process. Now it's time to calculate. I could key all of that in. In fact, I probably should, because it is a teaching exercise. So let's go. Square root of a fraction. 1.2 squared plus negative 0.8 squared, 0.2 squared, 2.2 squared, negative 2.8 squared, all over 5, and I get this lovely expression which I'm going to write 1.72 to the second decimal place. And that's the standard deviation. It's a natural measure of spread to pair with the mean. The mean is the measure of central tendency. The standard deviation is the measure of how bunched up or spread out the scores are around the midpoint. Now, as I said, this is really only practical if you have a very short number of items in the list. What happens if we have a more realistic scenario where we have a bigger data set? So let's imagine we have a data set that looks like this. Imagine I did a survey and the following scores were from the survey. We had 11, 12, 13, 14, 15, 16, 17. And these scores occurred with different frequencies. Well, the frequency of this one was 3, this one was 6, then we had a 12, a 14, we had an 11, we had a 7, and we had a 2. We need to do the mean. Well, there is a process of setting out an entire table and computational formulas. But because we have technology available, this will be acceptable in my class. If you're not in my class, check with your instructor as to what they would deem acceptable. So the mean, when we have grouped data, we will write the sum of fx divided by the sum of f. And here's where the technology is a godsend. We actually have an app here called Stats. So the Stats app is basically going to be this table, this tabulated form. So our first column, we're going to put the scores, 11, 12, 13, 14, 15, 16, and 17. The second column, I'll put the frequency data, 3, 6, 12, 14, 11, 7, 2. Quick reality check to make sure they're all there. Nice. Now, the F2 button gives us the options for all the possible calculations, the statistical calculations. Before I go launching into calculations, I need to check the settings with F6. And I can see here that this is a single variable, x. For one variable, the x values are stored in list 1, that's where I put them. But the frequencies, it hasn't got anything there. That literally means every score occurs once if it says a 1 here. So I need to tell this. I need to tell the calculator that the frequencies are stored in a list, and then it says where are they? They're in list 2. So that's better. The x's, the scores are in list 1, the frequencies are in list 2. That's good. Exit back to here. And now I'm going to press one variable stats. And bingo, it does the lot. It's worked it all out for me. It's told me that the sum of all the scores is 768. So I would put in my working 768. I'd still want to write the formula down, so I'm demonstrating my knowledge of the concept behind this. It tells me that the number of scores here is 55. Now I could divide those on the calculator, or I could just read the result directly from here. The mean is 13.96. Technology is a tool to be used. Now, the standard deviation. The sum. Now the only subtle difference between what I'm about to do and what I did a moment ago, where we had sum of x and then sum of deviations, we're going to have sum of fx, so we'll have sum of f, frequency, times the deviations. So my formula is sum of frequency multiplied by x minus x bar squared. Now last time I had divide by n for the mean. I had divide by n here. This time I'll have divide by fx. Sum of the frequencies is the same as the number of scores. And then square root sum. Again, it's important that you put all of this information here. Now, What does the calculator tell us? Here it is. Sigma x, the standard deviation, 1.48. And there's the standard deviation. We could do the thing by setting it out with the table and doing the computational formula, we would get the same answer. As I said, in my class, it's acceptable to use the graphic calculator and to write down the formulas and then substitute the figures given to find the standard deviation and to find the